Metallic bonds. As you are aware that metals have low electronegativity. Generally, these metals have one or two valence electrons, and the valence electrons are loosely held by atom. So these valence electrons, valence electrons are the outermost electrons. Generally, metals have, one or two valence electrons, and these valence electrons are loosely bound to the nucleus, and so they can be released easily. These valence electrons can be released easily. That means metals have low ionization energy, and hence they give up electrons easily. They can easily give up the electrons. These electrons called, these valence electrons which are released easily, these released electrons are called delocalized electron. Why they are called delocalized electrons? Because there is an equal probability of these electrons being associated with any atom in the crystal. We are calling it delocalized electrons because there is equal probability of electrons being associated with any atom in crystal. So they doesn't belong to the particular atom. They can be associated with any atom, and there is an equal probability, and hence they are called delocalized electrons. These delocalized electrons are forming electron cloud or electron gas. So in metals, what happens? Every atom lose its valence electrons. There can be one valence electrons or two valence electrons. If two valence electrons, then both are released, and they form a electron cloud. So when atom lose electrons, when atoms lose electrons, they become positive ions. So every atom in the metal lose their valence electrons, and so they form a positive ions, So you can consider these metals considered as is it is the array of positive ions embedded in electron cloud or electron gas. So there are positive ions which is surrounded by this electron gas. And this array of positive ions are more or less fixed places. Array of positive ions held at fixed places in crystal lattice by this electron gas or electron cloud. In other words, you can say that these free electrons acts as a glue or bond between positive ions. So this electron cloud held these positive ions together. So we have the delocalized electrons in metal. These delocalized electrons can move under applied elect under applied stimulus. Now this stimulus can be electric field or it can be heat also. So delocalized electrons are movable when we are applying the electric field or heat. So this metallic bonding are non-direction bonding. As you can see that they are held together, positive ions are held together by electron gas. There is no particular direction to the bond. So metallic bonding are non-directional as well as they are insensitive to structure and they form a weaker bond compared to ionic and covalent bonding or covalent bonds. Let's see the properties of this metallic bonds. Properties. Melting and boiling point. Obviously, it is higher. Then electrical conductivity is higher. It's a very high because there are lots of free electrons to move, which are called conduction electrons. So there are lots of conduction electrons which can be moved by using the electric field. These materials are very hard. Then they have malleability, and ductility. And metals are lustrous also, because they absorb the electrons and immediately they eject it. So they are lustrous.